Hello, this is OCR A-Level Chemistry going over an electrochemistry and redox question. It's from the H432/01, otherwise known as Paper 1, from the June 2017 series. So you're given a table and it's got standard electropotentials for 4 redox systems, and we're going to have to refer to this in all the questions below. So the very first part is a request for us to do a labelled diagram. Key here, labelled. Do not allow the examiner to try and guess what it is that you're drawing, of how the cell would be set up to measure the standard cell potential. So I've started off with basically two beginnings that are going to be the consistent each time. You're going to have a solution either side. You have to include the apparatus, the solutions and the standard conditions. So looking at the actual systems 1 and 3, make sure you do the correct systems. Please don't drop the marks that are given. So system 1, carefully looking, it's zinc as a solid, so I'm going to put an electrode in here and I'm going to make it really clear that that is solid zinc, and in my solution I'm going to have some aqueous zinc 2 plus ions, and that's going to get me 1 mark. On the other side, it's going to be this redox system 3, which is iron 2 plus and iron 3 plus, both as aqueous. So you need to have both of the aqueous ions, that's a comma there, if you can't read my amazing writing. So you've got the 2 aqueous ions in here. Now do not make the electrode out of iron at this point. You need the electrode to be something that's not going to get involved. So here we're going to use platinum. So this is going to get you the second mark. So now we have to set the whole cell up. Please use a ruler in your actual exam. Make sure you include a voltmeter, otherwise you cannot measure the standard cell potential. Now right here is the most common mistake that people make, because they've forgotten to put in the final part. Don't just again assume that the examiner knows what this is. Label it as a salt bridge. And if you want, go to town. Label that this is a wire. Make sure it's all clear. Not asked for here, but the wire is going to allow electrons to travel and the salt bridge is for ions. Now there are 4 marks. 1 for each of the 2 half cells, 1 for the diagram, and then reading the full question, make sure that you include what the standard conditions are. Temperature 298 Kelvin or 25 Celsius. Now we do have some solutions here, so you include the concentration as 1 mole per decimeter cubed. There's no gas involved, so pressure this time was ignored, but otherwise do make sure you include it, particularly if it's a question involving the standard hydrogen electrode, because you've got hydrogen as a gas there. Right. Question part 2. You have to predict the standard cell potential of this cell. So that's for redox system 1 and redox system 3. Now there's multiple ways of doing this. My preferred way is that you flip the less positive and then you add them together. So if we have a look up here, the less positive, well, plus 0.77 is obviously more positive than negative 0.76. So you would flip this one around. They're always listed as reductions, so the reduction will happen here, but this one will be where the oxidation is happening. So what you've got is plus 0.77, now you're adding to it 0.76, and that should give you 1.53 volts. Okay, on to part B. In the table, you're asked what's the strongest reducing agent and the strongest oxidizing agent. Just take some time to make sure you really know what you're doing with this. They're always listed, as I just said, as reductions, which means everything here is gaining electrons. So they're oxidizing something else. So they're actually listed as the oxidizing agents down on the left. The more positive the value, the more likely to be reduced, or, to put it the way the question needs, the more positive, the stronger the oxidizing agent that you've got here is. So in this case, plus 1.51 tells us that the strongest oxidizing agent, and I'm going to put acidified in brackets because it won't work without the H+, but the bit they really wanted was this manganate ion here. So that is what they wanted me to put. Now, to work out what the strongest reducing agent is, the reducing agent will itself be oxidized. So you need to look at the species which are going to be oxidized. But it's not the manganese 2+, because you're looking at the one that's most likely to be oxidized, and so actually now you want the most negative here. So in this case, it's the zinc. So the strongest oxidizing agent is the one that's most likely to be reduced, the highest EMF here. The strongest reducing agent is the one that's least likely to go from left to right, the one that's most likely to go from right to left. And make sure you get the chemical on the right hand side of this, which is the zinc solid. Alright, last part, be careful, this is when they use the other two. I would imagine a fair proportion of the most common mistakes here are where people have just kept on using parts 1 and 3. This time, again, read the question, slow yourself down in exams, make sure you get the right bits. It's 2 and 4. From last time, we're going to flip the less positive. So we're going to flip redox system 2. The next part, you need to make sure you've got the electrons balanced. There are 5 electrons here and 2 there. So we're going to times this whole thing by 5, and we're going to times this whole thing by 2. So if I flip this round and multiply it by 5, we've got 5 SO32 minus plus 5 waters, and then we're going to put 2 MnO4 minus plus 16 H plus. I'm not going to write the electrons in fully, but I'll leave them there just so you can see where my working's been going. Get 2 manganese 2 plus being created, 8 waters, sorry I've missed my state symbols, and then continuing from system 2, we end up with all of these. Now this will get you 1 mark. What you do to get the final one is cancel some things out. You see there's 5 waters on the left and 8 on the right, so these 5 waters are going to be cancelled out, and we'll be left with only 3 there. There are 16 H plus on the left and 10 on the right, so they will cancel down, so we get 6. Now don't leave it in this messy format. Make sure that you put all of the correctly balanced and cancelled out species clearly in the answer space. So you end up with 5 SO32 minus, 2 MnO4 minus, 6 H plus ions forming 2 Mn2 plus 5 SO4 2 minus plus 3 water. Okay, thank you very much.